So chapter 2 is just talking about forces and force as a vector quantity. We already talked about that means that it has what? Magnitude and direction. So you can't say that the force was 20 newtons and have it really make any sense. You need to know the direction, and then you also need to know what if you're dealing with a physical problem. You got the magnitude, you got the direction. What else would you need to know if you were dealing with a rigid body problem? Not displacement. If you're given a problem, I have a block that we placed 50 newtons of force along the x-axis. Does that really give you the full problem?
No.
Okay, what else do you need to know?
Without all the other implicit things, like is there gravity, is there friction?
Yeah, but even before you get to that, you need to know where on that block you placed the force, right? So you need to know the point of application. So we need the point of application for the problem to make any sense. Okay, because it's going to move differently if you put the force on one end as opposed to the other end, right? Okay, so the force is going to have a push or a pull effect. You're either going to be pushing the object or you're going to be pulling it towards you. It has some kind of the external force is exhibiting a force onto an object, and it's doing something to that object, right? And again, we're just looking at rigid bodies. So we're looking at something that is not going to deform when that external force is placed on it. So we need to know the magnitude, the direction, and the point of application. And of course, you're going to be given this in your problem. And I'll never give you any trick questions where you don't have something that you need to solve the problem. Okay. Forces have the principle of transmissibility. What does that mean? That is my stomach growling. I don't know if you can hear that. Yeah. Principle of transmissibility. So in rigid body mechanics, that means that we are not dealing with deformations. We look at the net external forces effect. What does this mean for you in a problem? This principle is going to be very important for you as you are doing these beginning sets of problems. If I have, let's say, a cylinder, and I have a force P that's being applied here at point A. So here's force P. It's a force, so it has magnitude and it has direction. Where is that force acting? What do we say? Point what? Point A. Okay, so we got point A. Let's say that we have another point B here and another point C here along the same horizontal line. What is the effect at B? Is there any effect of that force P? What about at C? What do you think? Well, what we're going to... Go ahead.
There would be an effect at B and C, right? Because it's on the same...
It's on the same line of action of the force. So what we're going to see is that the effect that this force P is having at point A is the same as the effect it's having at point B is the same effect that it's having at point C, because they're all along the same line of action. So this is very helpful when you are trying to sum forces. Okay, you can move that force anywhere that you need to for you to be able to solve your problem. When you're calculating moments or torques, which we're going to get to next week, you can move that force anywhere along the line of action so that you can get it to a point where you can calculate your moment arm, which we're going to talk about next week. So they have this principle of transmissibility, which is very useful for us in actually applying it to solve some of these problems. Okay, let's do an example.